Welcome to Breadboarding. This is video 51 in the Breadboard 8088 PC series, and this is part 6 of building a CGA video controller. So in the project so far, we developed a simple Nanocomp 8088 which had an LED display and keypad. Then we built out a basic floppy disk PC which was able to boot MS-DOS 330 and had a monochrome display adapter video controller. Now we're going on to the final step of this project where we're going to get a PC capable of running early versions of Windows, and we've already done the IDE disk controller, IDE BIOS and booting MS-DOS from hard disk, and now we've been working on the last 6 videos, the CGA video controller, so that's the Colour Graphics adapter video controller. Now in the last video we covered the building out of the first parts of the project. So really we were looking at just doing the basic CRTC, the clock, the dot clock, the IO port decoder and the video digital analog converter. So this was so that we can actually produce a test pattern, something like this, which we produced in earlier parts of the project. So if we just have a quick look at the board as it stands at the moment. So what I've done is I have moved the keypad and the LED display that we've been using up to now. So the keypad now has a slightly longer cable on it, so that's out of the way. And I've located the board here. I have needed to add some slightly longer cables, so I've added some extensions for these cables, so hopefully that will be okay. I might look at rearranging all the boards in future videos to try and make this a little bit cleaner. And if we just have a look at the video output as we power on the current board without having plugged in the CGA, we'll just boot this up. So you can see we've got the BIOS power on self-test. It'll look for something in the floppy disk drive. When it doesn't find that, it should then boot off MS-DOS from the disk. Okay, so that's running up there now. So that's working currently. So we know now if we break something, then it's something to do with the card. Okay, so what we're going to need to do in this video, we're going to need to take the various address and data lines over to the data bus over here and the address lines just over here. Let's just get rid of the video VGA there. And there's also the IO read and IO write that needs to go over down here. And in fact, we need to remember the E clock signal, which is the Motorola style clock signal. There is actually the reset and E signals are actually here as well. So we might actually get rid of the pull-up resistors for the reset and actually wire in reset as well whilst we're at it. So I'm going to wire those things in, plus what we also need to do is I've updated the CGA clock. When I was doing the subtitles for the video, last video I realised that I'd made a mistake and I had set the dot clock to be the dot clock and high res, so I've changed that and reprogrammed the clock PLD, so that's now correctly the 25 megahertz input and not itself. So that's been done, and we also then have got a test program. So this is a CGA test 1 program, which I'll go through in a little more detail as we progress. But what this basically does is sets up the video palette and the CRTC with the composite VGA compatible CGA configuration. This will then allow us to hook in some of the address lines from the CRTC into the video palette so we can actually get the test pattern. Okay, so I have soldered the power lines onto this connector here, and it goes up to the power distribution block at the top of the board over there. Now what we need to do now is to just wire in the data bus. The data bus is going to go over here where the data bus is, the lower 8 address lines going over there just a little bit off camera, and then the top 4 address lines we need are going just above that. And then we've also then got the IO read and IO write that need to go over here as well. So I'm just going to wire those in. And once we've done that, then we should actually be able to power the board, and we'll check to see what voltage we've got on the board first before we do anything else. So just plug in the IO read and IO write, then the data bus. Then we'll be doing the A0 to A7 address lines, then the A8, 9, 10 and 11. Now, one of the things I did forget to put in here, I did a bit later, is the I/O A19 to A12 line for the I/O decoder needs to go over to the left here as well, and that's the E signal. So we've wired these things in, and the E signal is going across to the bus over here. So let's just try powering it on just to see what voltage we get over here. So that's pretty good. We've got about bang on 5 volts there, so that's pretty good. So what we can do now is to look at running up the test software for this. So let's just have a more detailed look at that. So this CGA Test 1 assembly language program, I'm going to download this over the serial port like we used for the original NanoComp. I could actually try and assemble this actually under DOS, but at the moment, since I've got this all working already for the MDA card, I'm just going to use this version for the moment. So there's quite a lot of constants and things here. Basically this starts at the 7000 segment, so this is towards the top of the RAM. Now I've changed the addresses here, so these are now using the CGA addresses rather than the MDA addresses. You can see the video RAM segment now starts at B800, and remember this is segments, there's another 0 on the end there. So this actually starts above where the MDA RAM goes. For the moment I've just left it with 4K of video RAM for clearing the screen initially. We might want to change this to the full 16K once we have the graphics working. Then we've got the various digital analog converter registers and our control, colour and status ports. So to start with, all this is going to be doing is actually putting up the test number on the LED, 7-segment LED display. That just allows us to check which version is actually running. Then the CRTC loop, what this does is populates all of the CRTC registers. So if we have a look at where those values are located, so you can see down here, this is our CRTC table. So the values here are the same as what we had working with the 80 columns by 25 rows, and this was working at 70 Hertz. And so all these values are the same as what we had previously. So we're going to start with that, and then obviously we'll look to tweak and modify things if needed. Then we've also got the palette. So this palette here is the optimized one. So this one should match the CGA colors pretty closely. If you remember when we first did this with the monochrome display adapter, we also got it outputting color as well. So the color here should be pretty accurate. And what I've also then done is added some grayscale here, so we can actually try and run the CGA card in black and white mode. This would only work with the composite TV output. We've got some grayscale values here. Whether or not these are mapped properly for the combinations, we'll have to check and see. So to start with, all this is going to do, so it initializes the palette, outputs the red, green, blue values for each of the entries, sets the control port to the appropriate values. Now at the moment the control port's not wired up, so that doesn't really matter at the moment. It will currently do clear screen, although we haven't got any video RAM, and then it will just do an int3 to go back to the monitor. So at the moment, outputting all the numbers along the top and sides of the screen, and also outputting the attributes and the font information, there's no point in doing this yet because we haven't actually got that far. So we're going to assemble this using NASM and then download it over the serial port, and then what that should do is once the program's been run, we should then be able to check with the logic analyzer to see if we've actually got any of the appropriate signals coming out of the VGA port. Okay, so let's now assemble the test program. Now I've hooked up the serial connection onto the COM port on the Breadboard PC. Just going to power on the Breadboard PC and put it into load mode, and we're just going to send down our SREC file. And then on the keypad I'm just going to run the program. So that's now running. So what we're going to do first of all is have a quick check with the oscilloscope to have a look at a couple of the signals. So firstly you're just going to have a look at the clock. So this is a dot clock. Let's see if we've got a value here. We might just need to change the time base. Okay, so what we can see here is that we've got about 25.2 to 25.17 megahertz, so that appears to be the right sort of dot clock. So let's have a look at the output dot clock to the video DAC. Okay, and that's also around about 25 megahertz, a little bit smoother that one, but that's still okay. Just have a look at the character clock. So we might just need to change the timescale for this. The character clock's about 3.1 megahertz, which is what we expect. So that's looking good. So now we're going to have a look at the horizontal sync and vertical sync. So if you look at the horizontal syncs, that's basically the end of each line will actually go high. So if we have a look there, we can see that that's about 31.5 kilohertz. So that's how long it takes to do each line on the VGA screen. So that looks to be approximately right. Now if you look at the vertical sync, we'd expect this to be about 70 hertz. Again, change the frequency. And yes, that's 69.808 hertz. So yeah, that looks like that's correct as well. So it looks like these values are fine. I had to do a little bit of debugging on the board. I had missed out one of the IO A19 to A12 lines, and I'd also missed out changes to the 6845 chip select. So in fact, the CGA decode, in fact, there was just a few changes to this line here. Basically, these values here were not consistent with all the others, so I just missed out. I must have finished the other ones and not done this one. So that's been changed, but other than that, then it all appears to be working. So what I've also done, if we have a look at the board here, you can see this is the oscilloscope probe, and I've also got the logic analyzer on here as well, so it's on the data port and there's various other values. So we'll have a look at what's going on there in a minute. And what I've also done is I've wired up the address lines for the CRTC here to the video palette chip, is what we were talking about previously. And we're going to see now whether or not we can get the pattern close to what we had previously. So I've already run the program, so it's plugged into the VGA port. See here, I've now plugged it into the VGA port. And that does look like we're getting almost the pattern that we expect. Just go to the full screen. There's a little bit more black there than we're expecting. So some of the colours aren't quite the same, but it's looking pretty reasonable. We're definitely getting various blues, reds, yellows, whites and things, blacks. There's a few blue ones aren't quite coming out right. So just try running the program again. And what I'll also do is record the signals on the logic analyzer. So in fact, the colours have changed, so that's a bit odd. Let's run it again. Okay, the colours are back again. So it looks to be some sort of issue to do with writing the palette information. I have had problems in the past with the timing of updating the palette, so I probably need to look at that a little. But it looks like it is actually working largely. There's just a bit of an issue to do with writing to the palette, so we'll have a look at that. But I think that's looking okay. If we just have a look at the... So this is the logic analyzer. We've got the data lines, the dot clock, character clock, the IO read, IO write, the chip select for the 6845. So we can see here, this is where we're writing the register values, and so 6.3, for example, is the horizontal length of the line. I think displayed should be 5.0 there, so that means that's 80 characters. So that's where we're writing the values to the CRTC. And then we can also see here we're writing the values to the palette. So you can see here FF is when we write to register 2, which is the pixel mask. So we set that to FF. And then we should see generally we write to register 0, value 0, so that is the palette entry 0. Then the next 3 bytes should be the value. So we've got black 0, 0. We should have another 0. Yeah, so we've got zeros there. We'll just have a look at the next one. This should be blue, I think. So palette entry 1 is 0, 0, and this next one here should be 3.1. Yeah, so it looks like some of those are going in okay, but not all the palette values seem to be being recorded properly, so I'll need to have a look at that. So it looks like we've got our test pattern. If we compare the two, so that's what we had from one of the earlier tests, and this is what we've now got. So there are a few differences, and you can also see on the right hand side here, because we haven't sorted the timing out for some of the vertical sync and display enable, then we've got the odd character bleeding there, but we've largely got what we'd expect. We've got the colours coming out. They are changing by the various CRTC address line outputs, so we just need to have a little look and see why some of the colours are not being set properly. So I think I'm going to break the video there. So what we'll be looking at in the next video is we'll start to put the video attribute multiplexing and the output video PLDs, and we'll also look at programming the character ROM and see if we can actually get a character test pattern to come out on the screen in addition to just the colours. So if you don't want to miss out on future videos, then please hit subscribe, and if you could hit like as well if you found it interesting. It just helps to make the videos available to more people. Thanks for watching.